Hello, welcome to the second part of the video where I'll be implementing a 4x4 multiplier using IP generated modules. In the previous video, we discussed about generating IP modules to perform 4x4 multiplication on the De1-Soc board, and we provided the output on the LEDs. In this video, we will build on top of the module, but instead of outputting it to the LEDs, we'll be using the 7-segment display provided on the De1-Soc board. So for this, the base module remains the same, where we used in the previous video. We'll go to IP catalogs, basic functions, arithmetic, and multiplier. From that, I generated this module. Only difference is, instead of using default optimization, I've used the speed optimization, where this module will be compiled in such a way that it is optimized for speed. The top module has connection to 3 submodules. The first one is the multiplier, where it takes the data A, data B, and generates the multiplication result. So the multiplication result from the multiplier is sent to binary to BCD conversion module. So this module converts the binary data to a required BCD so that individual units, tens, and hundreds can be displayed on the 7-segment display. Next, I call the hex decoder. Hex decoder is basically a decoder for the 7-segment display, which will take these individual units, whether it is ones, tens, or hundreds, and generates the respective signal required for the 7-segment display. Our 7-segment display is an active low system. The display segment to be on, we'll have to provide signal 0, and to be off, we have to provide 1. So for 0, the signal will be 1 followed by 5 zeros. In the same way, I've written the signals data for all the numbers from 0 to 9. And we'll be calling this module for units, tens, and hundreds place. Based on the number whatever we have generated for that respective number, the signal assignment will be done. The signal assignment is done using the signal assignment is done based on the documentation provided by De1-Soc, where they have provided us the pin numbers and the pin location, based on which we'll be assigning the pins to the respective signal. We'll go to assignment, pin planner. For the pin assignment, we reuse the same switches for the input, but in the output, instead of being the LEDs, I've assigned it to the 7-segment display. So programming the device still remains the same. Open the device programmer, select your chip, and edit the file as per your generated bitstream, and then click start. So this will program the device. Once the bitstream has been uploaded to the board, we can see that the 7-segment display has been activated with value 0, since all the switches are in 0 position. So our inputs are 0 multiplied by 0, so the output will be 0. Let us toggle switch 1, so it will be 1 into 1. You can see the output is 1. Let us do 1 into 2, output will be 2. 10 into 10 will be 100, 15 into 15, 225, 12 into 12 is 144, 8 into 8 is 64, 8 into 9 is 72, and so on. So we can see our respective multiplications are being performed and being displayed correctly on the 7-segment display. Here you go, friends. So that is the 4-bit multiplier using IP generated modules provided by Altera and being driven on the De1-Soc board, where our inputs are being controlled by the switches and our output is being shown on the 7-segment display. Thank you and have a great day.